Good afternoon, and thank you for participating in today's webinar on servicing Follett countertop and under-counter refrigerators and freezers. My name is Cindy Fitton, and I am the Senior Product Marketing Manager for Follett's Healthcare product line. I will be your moderator for today's webinar. Before we begin, I'd like to review a few housekeeping details. To facilitate the audio of the presentation, attendee audio will be muted. But we want this session to be interactive and we'll be asking for your feedback throughout the webinar using polls. Please provide your answer in the poll as soon as it appears on your screen, and we will share the results with all of the participants. We'll be taking regular breaks throughout the webinar for Q&A, and you can ask a question using the Q&A window on your screen at any time, or you can raise your hand using the hand icon, and I will respond via chat or pose your question to the presenter. We want to be respectful of your time, and we'll do our best to keep the length of the webinar to 75 minutes. We'll answer as many questions as time permits, and we're also happy to stay on the line after the conclusion of the presentation for open discussion, at which time we will unmute attendee audio. So at this time, I'd like to introduce our presenter, Mr. Ernie Taroff. Some of you may already know Ernie from his 26 years with Follett. Ernie is our National Technical Sales Support Manager and comes to us with a wealth of knowledge about Follett's healthcare products. Ernie?
Thank you, Cindy. Good afternoon, everyone. Glad you could join us here today as we're about to embark on our next webinar. This morning we covered installation and setup of the under-counter and countertop refrigerators and freezers. So this afternoon we're going to be talking about servicing them. So what is on our agenda? Okay, first off, we're just going to briefly review the freezer types, refrigerator and freezer types that we have available. And as I mentioned, this will be specific to countertop and under-counter units. So we'll be looking at service access, okay, component locations, where are all the parts and pieces, the control system, obviously that's the heart of the refrigerator, the brains, if you will. Probe validation, that's an important aspect of keeping the units working properly, the electrical operation, and then a refrigeration overview. We're not going to, don't have time here to make this a refrigeration course, but we'll be talking about some of the things that are unique to the refrigeration systems of these units. And we covered this in the beginning this morning, this morning's webinar, and we suspect that we may have a lot of those people attending this afternoon for the other part of the story. So because there was a lot of technical content, we're going to hold off on the customer support resources until last. So those that have already seen it, they don't have to linger if they choose not to. And for those who would like to get that information, we certainly will make that available. And then at the end, finally, question and answer session. So I would like to start off, okay, Cindy mentioned some surveys, and we like knowing a little bit about our audience, who is tuned in with us here today. So the first thing we would like to do is ask you, have you previously attended a Follett service seminar before or a webinar? So if you wouldn't mind responding to that, placing your answers here, casting your ballots, if you will, as we approach voting season. We're in voting season as we approach the voting day. Yeah, it looks like a lot of you have already attended Follett service training. Very good. We still have some people logging in here, I see. Okay, that's pretty much, I think that's good enough for the moment. We have a lot we have to cover today. So here are the results. So obviously a lot of you have been to a webinar or a seminar before. So that's excellent. We're glad to see that. So what we would like to know, in addition to that, and those of you who have already been through one of these, I think you know where I'm going with this, is have you worked on Follett equipment already? Are you experienced with that? Okay, we still have a few ballots coming in, a few votes happening. All right, we'll share that. So very similar to this morning. It's almost 2-to-1. 2/3 of you have worked on Follett refrigerators and freezers before. Those of you that haven't, we hope that this webinar, makes that first experience, as easy and simple as possible. And I certainly have resources that I can share with you that'll help you if you run into any difficulties. And then the next thing that we would like to ask is, what type of organization do you work for? All right. There we go. Okay, do you work for a hospital? Do you work for a refrigeration service company? Perhaps you work for one of our factory authorized service providers. Zoom picking up a familiar theme here. And it looks like it has stopped for the moment, so we'll stop it here. And obviously the vast bulk of you are work at a hospital, and I suspect that I already know the answer to the next one, but we're still going to ask it anyway. Okay, what is your role where you work? Are you a technician? Are you a supervisor? Director? Let's see who's out there. Oh, good, excellent, excellent, excellent. I like seeing directors and supervisors in attendance. It's always a very good thing. Okay, looks like this has stopped now. And the bulk of you, as you see right here, are service technicians at a hospital, okay? And just to let you know, in case you weren't here for this morning's session, I am a tech myself. I've got a big fancy job title, which just means I'm a tech that teaches, okay? But I work on this equipment myself, so please feel free to ask your questions. If you have questions as we're going through the presentation, I don't necessarily have all of the answers, but I'll answer what I can, and if I don't have an answer, I'll do my best to get back to you. So first thing we want to let you know, like I said, we're going to skip the preliminaries about, navigating our website, those resources, but we do want to make sure that everyone knows about how to reach tech support if you have a question or a problem. And this is the number, as I mentioned in this morning's session, the sales literature that you get from your sales representative, specification sheets, that sort of thing. There's an 800 number on there, but that's intended for reaching customer service. That's if you're looking for a price quote on equipment, check on the status of an order, you'd want to use the 800 number for that. But if you're looking to reach tech support, this is the number you want to use. The reason being, the guys are there answering the phones 8 a.m. to 5 p.m. Actually, a lot of working off-site these days, given the current environment. But we're answering the phones from 8 to 5. When 5 o'clock, the switchboard shuts down. However, there's a tech on call for 3 more hours until 8 p.m. Pardon me. And also from 8 a.m. to 8 p.m. Saturdays, Sundays, and all holidays except Thanksgiving, Christmas, New Year's, Easter. Then he gets a break. The rest of the time, you have support available 12 hours a day. But the only way you can reach the on-call technician is through this number, not the 800 number. If the switchboard is closed when you call, you will hear a recording, and it gives you various menu options, including how to reach the on-call technician. So please listen to the message, and it will give you the prompts that you need for the access that you're looking for. Also, our technical service department can be reached by email, and that's at techsupport@followice.com. The main reason I wanted to put this up here is if questions or anything that you would like to discuss should occur to you after the conclusion of the webinar, if you think of it later, you can send your questions to techsupport@followice.com. If you're looking to communicate with me, all you have to do is put refrigerator and freezer webinar in the subject line, and then I will respond to that. Those will get directed to me, and I'll get a chance to work with you and answer any questions that you might have. So that's the basics insofar as communicating with Follett with tech support. So the first thing we're going to look at are the different refrigerators and freezers that we offer. Just a brief product review. We basically categorize them one of 3 ways. We call them pharmacy, blood bank, or lab models. So over there on the left, okay, that's a 45 cubic foot double door upright. That's an example of our pharmacy unit. They feature roll-out baskets. They're on stainless steel ball bearings, so they glide very easily even when the baskets are fully loaded. So that's a pharmacy model. In the middle there, in our 20 and 25 cubic foot line, that's an example of a blood bank unit. Blood banks prefer solid stainless steel drawers to the basket, so that's why the difference is there. In addition to that, you can see in the upper right-hand corner, there's a chart recorder. Even though these units digitally log temperatures, they still want that piece of paper. They want that chart, so certainly we are going to provide that so they have what they're looking for. Another difference between the two is the product simulation bottle. On our 12 series, which we'll talk about in just a moment, it's over here on the right-hand side. On the 25, 50, and 45, it is on the left-hand side where the door opens. So we place that bottle there. The difference with the blood bank unit is because of the solid stainless steel drawers and the challenges they present to even air distribution. AABB knows that they want the temperature monitored at the top and at the bottom. So there is a second bottle and probe down at the bottom to monitor that temperature as well. That's optional on other units. You can get that if you'd like to, but it comes standard on the blood bank units. Next, 12 cubic foot. This is the newest refrigerator in our lineup. That is a slimline unit, as we call it, and this is shown in the lab configuration, which just simply means it has shelves that don't slide in or out. They're just, you can adjust the heights, but they are stationary. So that's the difference between the three. However, today what we're going to be focusing on is the under-counter unit. That's the 4 and the 5 cubic foot that you see there. Basically, they're the same unit. The only difference is the height. A 5 cubic foot refrigerator or freezer will not fit under an ADA compliant counter, which is why we introduced the 4. That one will. It's a little bit shorter, and that will fit underneath an ADA counter. If you're not looking to fit under tight vertical clearance, by all means, suggest you go the 5. You get a little bit of extra storage room. If not, we have a smaller version available for you. And then underneath that, 2 models, a 1 cubic foot and a 2 cubic foot refrigerator and freezer. These are intended as countertops. You put them on the counter in the nursing area. So we have different ways of locating these different units. Regardless of which unit we're talking about, pardon me, they all come with a 2-year, I'm sorry, got ahead of myself here, parts and labor warranty, and an additional 3-year part warranty on the compressor for a total of 5. The reason that I'm mentioning this is if you have a problem during the warranty period, certainly we hope that doesn't happen, but if it should, we ask that you contact tech support at that 877 number, and we'll be sending out a service provider to take care of the issue for you. However, a lot of hospitals have their own service staffs, have their own maintenance staffs. We are quite confident in your capability. If you want to, you can work on your own equipment during the warranty period, and it does not void your warranty. All we ask is that you work within your skill set. If you're an electrician and not refrigeration certified, please don't go into the refrigeration system. That's all. And if you have questions, call us, or we'll be happy to dispatch the service provider. It is your call. So what we're going to be looking at, okay, is first the component locations. Where is everything located on these units? And we're going to be starting off with the countertop. And we're going to be looking at the rear service access. Now, this presentation is a combination of videos, which will actually demonstrate access to these locations, and there'll be times I'll be working off the PowerPoint, and there's some key things that I need to mention specifically to you. So with this, we're going to start our first video. Follett countertop refrigerators and freezers draw the cooling air for the air-cooled condenser in at the top of the upper service panel. In order to clean the condenser, remove the upper service panel, and that will give you access to the air-cooled condenser. You can go in with a shop vac with a brush attachment to remove the dirt and the lint from the condenser. Follett recommends deep cleaning the condenser with compressed air every few years. For further service work, the lower service panel can be removed, and if need be, the service wrap that goes around the entire unit. To remove the wrap, there are 2 vertical Phillips head screws that need to be removed. Then there are 6 Phillips head screws that only need to be loosened, 2 on each side, 2 at the top. Once the screws are loosened, the wrap can be lifted up and off of the unit. Removing the lower service panel and the wrap will give you access to the compressor, the condenser fan motors, and to the condensate pan on the left-hand side of the unit. So that was the the countertop unit. The next thing we're going to be looking at is the rear service access of the under-counter unit. To access the condensing unit on Follett under-counter refrigerators and freezers, the unit can be partially withdrawn from the rear of the unit without having to disconnect any refrigeration components. The first step would be to remove the front cover, the bottom of the unit, and to remove the baffle from the right-hand side of the condenser. It is very important at the end of the service that this baffle be reinstalled to ensure proper airflow during normal operation. Once you have removed the baffle, Then from the back of the unit, remove both service panels, the one covering the refrigeration tubing and the access panel at the bottom. Once the panels are removed, remove the two 1/2 inch bolts that secure the condensing unit to the base. The unit can now be partially withdrawn, giving you access to the condenser fan motor, the condenser fan blade, the compressor, and the compressor starting components. Something I would like to mention about that first step when we're removing the front panel and that little side plate there, that baffle that's in there, that is a critical component because the purpose of that, it prevents recirculation of the air coming off the condenser, and it prevents a return to the low pressure area in the front where the air goes through a second, third, and fourth time. So it's that baffling in there that enables this unit to totally front breathe. It does not require any top, side, or back clearance whatsoever, as long as that baffle is in place. Now, if that's not in place, then we're going to get recirculation, which is going to drive head pressures up in the refrigeration system. Now, the securement method that we just saw there, that is what we're using today. It has changed a little bit over time as our product has evolved. On previous models of Performance Plus, it's a little bit different. So we still have that rear panel and that chase that enables you to pull that the condensing unit partially out for service work. But prior to serial number, this is where we come and talk about serial number breaks. So when we make a significant change, we note the serial number. So on prior to this number, K25542, you still remove the rear panels, but there are two Phillips head screws that are horizontal. So the same principle, just it's secured a little bit differently instead of the vertical bolts, which, by the way, is on the original what we call legacy units. Those were vertical bolts as well that secure the condensing unit to the base of the unit. So we've looked at the front access. Now it's time to look at the we've looked at the rear access. Now it's time to look at the front access, and we're going to be doing that first with the under-counter unit, since that's where we're at the moment. Next, we're going to cover service access from the front of the unit. Both the air-cooled condenser and the electrical control box and control board are accessed from the front of the unit. For units that have a touchscreen, there is a door alarm sensor installed in the front panel, so take care when removing the panel. As with any refrigerator or freezer, the air-cooled condenser needs to be kept clean. On the Follett under-counter refrigerators and freezers, the condenser is accessed from the front. By removing the lower front panel, the condenser can be seen on the right-hand side of the unit. All Follett under-counter units have baffling to prevent recirculation of exhaust air coming off of the condenser. The units will totally front breathe. It's important to remember that air-cooled condensers on under-counter units tend to accumulate dust and lint more rapidly than units located on a countertop. Air filters should never be installed in front of condensers on any Follett refrigerator or freezer. The condenser fan motors are not designed for this. A shop vac or a vacuum can be used with a brush attachment to remove any dirt or lint from the condenser. Follett recommends deep cleaning the condenser with compressed air every few years. In this particular unit, in the center, we can see the lock mechanism for the keypad lock. This is found only when the Follett keypad option is installed at the factory. The electrical box is accessed on the left-hand side of the unit. To remove the electrical box, loosen and remove the vertical knurled screw. Then the front of the electrical box will drop down slightly and it can be pulled forward and laid in front of the refrigerator. So that's the component access from the front of the unit. So one of the things I'd like to point out here is on that air-cooled condenser, as I mentioned, units with the condensers down near the floor do tend to pick up dust and lint fairly rapidly. Normally, the shop vac with a brush attachment does a very effective job of dealing with that, but over time, gradually, some of this gets embedded deeper into the fin block of the condenser. So occasionally, maybe every 2 years or 3 years, you'll know based on, observation, it's a good idea to do a deep cleaning of that condenser using compressed air to blow out that accumulated dust and lint that tends to build up in there gradually over time. Now, just as the front was, the rear axis changed at model serial number K25542, the front did as well. Oh, Cindy, do we have a question?
Yes, Ernie, we do have a question. What key is in front of the coil?
Okay. If they're referring to what I think they mean is that black plastic cylinder, and that is the lock mechanism for the keypad lock accessory. There is a key lock on the unit, but it's on the left-hand side of the door as it's set up with its standard right-hand swing. I think that's the intent of the question.
If that didn't answer the question, please chat in another question and we'll make sure we clarify that.
Absolutely.
Thanks, Ernie.
Thank you, Cindy. Okay. So at that serial number, there were a few other changes as well, besides the way that the condensing unit is secured to the base of the unit when we pull it out from behind. The electrical box was different also. As you saw, the box on the serial number higher than this, that was mounted horizontally. Originally, it was mounted vertically on this plate that you kind of see right here. We'll be able to clarify that in just a moment. That plate is locked in place by the knurled screw that you see right here, or the thumb screw. So we need to loosen and remove that thumb screw, and then the whole plate gets pushed toward the back of the unit. Because as you can see, there's a hook that's on the bottom of that plate, and that locks into a bracket that's down here at the base of the unit. Back with the question.
Yes, we have another question. How many probes does this unit have?
Okay, we're actually going to get to that. I'll answer right now. The refrigerator has 2. The freezers have 3. But we're going to be looking at those in great detail in just a little bit. Okay, so we're not going to skip over that topic. So you can see that the box is mounted here. Up at the top, there's a shoulder screw on a similar bracket up at the top that fits into a notch up at the top here. So you need to push that panel to the back, move it over to the right-hand side to disengage it from those brackets, and then it pulls out and lays in front of the unit. And it gives you access to the control board and to the relay, which we'll be looking at in more detail in just a moment. Now, on those units, because the control board is down here, but the user interface is up here. This is Performance Plus, all right? There is a communication cable that has to go between that control board and the user interface up at the top. So depending on when it was made, all right, there have been some changes here as well. The original ones, okay, before serial number, that cable was routed through the front panel. So when you remove the front panel for cleaning the condenser, you have to just take care that we don't damage that cable. There is a plastic grommet, and this shows it here a little bit, but this is the new style. All right, there's a plastic grommet that protects the cable, all right? And there's a plastic sheathing that goes over that. So there's 2 layers of protection even before we're talking about the insulation on the wires. When reinstalling that rear panel after a condenser cleaning, please make sure that the plastic grommet is in place and that the sheathing has not worked its way down and that we're rubbing bare wire here, because if that happens, it's going to cut the communication cable. So it's just a final check as you're putting the unit back together after a condenser cleaning. All right, so that hole is in the panel that you see right there. Now, after that serial number, we made a change, all right, and that was right here. You might be able to see it. There's a relief cut around the front panel, and we changed the shape and the forming of the side panel. So that cable now goes through the side panel. It's no longer through the front panel that you see right there. So when you remove that, the cable stays in place. We still advise you, it's a good idea, just check the sheathing, make sure that it hasn't slid down the wires, make sure that it's in place all the way tight up against the base of the door where the communication cable enters the door, going up inside there to the user interface, and again to make sure that that grommet is in place before you put the unit back in service. So that's the under counter, and we should look at the countertop control board access too. That one's a little bit different. To access the control board on a countertop refrigerator or freezer, unlock the door, open and prop it open, then remove the 2 Phillips head screws at the bottom right and left-hand corners to remove the front panel. Take care of removing the panel. There are wires connected to the interface that are attached to it. Set the panel aside. Then, on the left-hand side, you will see a mounting plate with a Phillips head screw. Remove the single Phillips head screw and then gently remove the mounting plate and components. And as you can see, I'm still getting used to doing webinars. I do pretty good with stuff with Freon in it, but I'm still learning all of this high-tech stuff here. So that shows now the control board access and removal. On the countertop units, there have been no changes to that. That's still the same as from the original ones that we introduced years ago. And here now we're getting to, so we've seen the control board. What ties into that, of course, is the probes. And here we're going to answer the question that we had earlier. So we're going to show the locations. And as I mentioned, refrigerators have 2 probes, freezers have 3. On the refrigerator, we call the refrigeration control probe P1. This is the one that actually controls the temperature of the unit, controls when the refrigeration system runs. The P3 probe is in the bottom. This does nothing more than report, so they're completely independent. They do not communicate with each other in any way. P1 controls, P3 reports. This is the temperature we're showing in the display, and this is also the one that we use for temperature alarming. Now, P2, we didn't neglect that one, didn't forget about that. That's only on freezers. Your P2 probe, and it's not in sight here, but we are going to look at it in just a few minutes. That is embedded into the fin block of the evaporator coil itself. It monitors the temperature of the evaporator coil, and we use that for terminating the defrost cycle. We don't want the units to be in the defrost cycle any longer than they have to be, and so that's why we monitor that temperature, because of course when you're defrosting the unit, you can't be providing and delivering cooling to the product. So on the control probes, okay, a couple of things. Number one, when you're putting product in there, we need to make sure that we don't block the airflow. All right, these are forced air cooling units. Now that gives them fantastic recovery performance. They recover temperature very quickly after door openings, because we're forcing the air through that actual heat exchanger, that fin and block evaporator that's behind that rear panel that you see right there. So we need to make sure we don't block any of that airflow. Next up, okay, please make sure we don't have product pushed up against the control probe. Otherwise, you're not going to be controlling. Now, we have a rail, as you can see right there, that's built into the shelf that normally does a very effective job of preventing that from happening. It prevents the staff from pushing product in the back up and against the probe. However, I have run into instances in the field of, shall we call it, creative product loading. In one memorable location, I was in a pediatric area at a hospital, and when the nurses received their vaccines, all those little boxes, they were in what was essentially a large clear plastic trash bag. So what they did is they removed the top shelf and put the whole bag inside the refrigerator. Well, that, number one, it blocked the airflow. Number two, we had product laying on top of the probe, and so we lost control of the refrigeration temperature. So just be alert to that, okay? The other thing that I like to remind the staff, and occasionally it does require a general reminder, you can't store 5 cubic feet worth of product in a 5 cubic foot refrigerator or freezer. That's simply not going to work. You need to allow the air to move around it. If you pack it totally full, it's going to have a hard time maintaining accurate temperatures, all right? And on countertop units, those shelves do not have a rail. So what we have is we have a little stainless steel guard that clips onto those slots you see right there in the louver, okay? And that protects that probe from contact with the product. If you can't keep the staff from pushing product up against it, even with that rail on an under-counter unit, that guard will work on an under-counter unit. The slots are the same. So you can do that as a last-ditch alternative if you can't keep the staff from pushing product up against that control probe. So this is the refrigerators. We've looked at that. We should also look at the component locations on the freezer. So it's in addition to everything that we've already seen so far. And that brings us to our next video. On Follett under-counter refrigerators and freezers, the evaporator is located behind the rear wall panel of the unit. To access the defrost components on an under-counter freezer, First, remove the 6 Phillips head screws securing the panel to the unit, and then loosen the screws on the bracket on the left. Remove the screws on the shelf bracket on the right, and then the panel can be pulled forward. Components inside include the defrost termination probe, which is labeled the P2 probe on the control board. The purpose of this probe is to terminate the defrost cycle when the evaporator temperature reaches 5 degrees Celsius, which is the equivalent of 41 degrees Fahrenheit. Slightly above that, there is a safety switch, commonly called a click-on, which will take the heater offline if the evaporator gets too hot. This is a safety feature, and that switch should be closed all the time. There are 2 defrost heaters, one on the face of the fin block for melting the accumulated ice on the evaporator. The second is in the evaporator drain pan. This is a lower wattage unit, and its only purpose is to make sure that as the water drips into the pan, it does not refreeze. Attached to the heater in the drain pan is a piece of wire which extends down into the drain tube. The purpose of this is, again, to prevent water from refreezing once it enters the drain. It is important that this wire be connected to the heater. As you were able, we have a question.
Yes, we do. So before we carry on, is there any consideration currently being given to changing the design of the P3 probe media bottle holder, the stainless steel bracket holding the bottle, so as to prevent accidental dislodging due to overloading? The tape often fails.
If there is, I'm not aware of it. However, we do rely on customer feedback such as this. If you're having a problem with that, this drives a lot of change to our product as it evolves over time. So, certainly, an email to techsupport@followlights.com. Again, just in that subject line, put refrigerator freezer webinar. And as we naturally, the more we hear about this from more people, that drives that change forward on our to-do list. So if you're having issues like that, then yes, we appreciate hearing about it. But at the moment, as far as I know, there's no initiative at this time to make any changes there.
And I would confirm, I've not heard it before either, so I don't believe there's anything in place. But if other people are also having the same problem, if you can all send that email into tech support and the refrigerator freezer webinar so that it goes directly to Ernie, we can take that to our engineering team. Thank you.
Absolutely. And in that whole same light here, one point I would like to make, as a technician, I would be foolish to say to you that you're never going to have a problem with a piece of Follett equipment. That's in no manufacturer can claim that. What I can tell you is that if you're having a problem, we won't run away from it. But we can't fix a problem we don't know about. So the last thing we ever want a customer to do, whether it's something like this, a little inconvenience thing where it's annoying, or if it's something serious, please share it with us. We need to know about that because we do make changes to the product, based on the feedback we get from our customers. It's important that we have satisfied customers out there because, frankly, from a business sense, we don't want your business just today. We want it next month, next year. We want to earn your business. And so please tell us, share us. And thank you for bringing that to our attention today. I do appreciate that. So next up, this was the under-counter freezer. One other point I'd like to make is you probably noticed that the defrost heater, now that's the high wattage heater that's on the face of that evaporator, it's directly behind that rear panel. Now that panel does a pretty good job of isolating the defrost heat away from the product, provided the product is not shoved up against the wall. So on a freezer, it's important to make sure that the staff is not doing that because it will pick up some of the heat from that defrost heater during the defrost cycle. We need to leave a little gap there, okay? If it's pushed up against the wall, then that's going to pick up some of that heat when the unit goes into defrost. So that's the under counter. The countertop is a little bit differently. All under counter and countertop refrigerators have that back wall design. However, the countertop freezers are a little bit different. They have a more conventional ceiling mounted evaporator, which is what we're going to look at in the next video. To access the P1 control probe or the P2 defrost termination probe, remove the single vertical Phillips head screw from the assembly, remove and set aside the cover plate, and then the P1 probe you'll see mounted on the underside of the top of the unit next to the safety switch, and the P2 probe is in the fin block. The third and final probe, the P3 probe, is our bottle probe. This is the probe located in the product simulation bottle. This is the temperature that is seen on the display of the unit and is used for local and onboard temperature alarming. So there are the probe locations on the countertop freezer. I should just mention here that if that probe ever needs to be replaced, obviously we saw on the under-counter unit, it's simply vertical down in the fin block. That's pretty straightforward. Just please put it back in the same location as the original. On the freezer, the countertop freezer, it's a little bit differently. It's mounted horizontally, but it's also angled slightly. The part that's embedded into the block is a little bit higher than the wire connection. So again, when you're replacing it, if that should be necessary, we not only want it in the same location, we want it angled at the same angle that the original one was set. Okay, so that's the water runs off and it prevents it getting into the wiring there because of the horizontal location, horizontal position is the word I'm looking for here. So that's all we have for the probes, all right? And seems like everybody's been asked their questions, but if there's any more on the probes, we'll certainly address those before we actually get into the standard controls of the unit. Any more questions, Cindy?
No more questions, Ernie.
Okay, away we go. All right, so the standard controls, all right, and this is what you can see on the right-hand side there, the two right units. This is really the only one of it. This is the only one available for countertop units. As you can see, there's not a whole lot of space there. On the under counter, the standard control, okay, is the regular option. However, we can also go to a touchscreen option, which we'll be looking at in just a little bit here. But for now, we're going to cover the standard controls. If we zoom in on that, this is what you're going to see. And so let's go through those buttons one at a time. We'll start on the left-hand side. So the first one, that speaker with a slash through it, that is the mute button for the audible alarm. If the unit goes into alarm mode, there will be both an audible and a visual alarm. It will show that in the display as well. So if the staff wants to silence the unit, they can do that simply by touching that button on the far left-hand side. That will mute the audible alarm. If the alarm condition has not been corrected within 10 minutes, it will ring back. It will go off again, and it will continue to do that until the alarm condition is taken care of. The visual alarm, however, whether the alarm condition is satisfied or not, that stays. That is not going to go away. It has to be clear. The reason that we do that is suppose this unit is placed in an off-site clinic, maybe that's not manned 24 hours a day. Suppose there's a power outage during the night and we don't have backup generators at that location. So what's going to happen? The unit shuts down, the temperature is going to go up, okay? If power is restored before the staff returns in the morning, the unit's going to fire up, and so the audible alarm will be stopping, okay? However, the staff won't know there's anything wrong unless we keep that visual alarm there. That's why that stays. So when they come in the morning, they see that, they know something bad happened during the night, and then we can do some investigation. So in order to clear the visual alarm, all the staff has to do is touch and hold the set button. Wait, it takes around 6 or 7 seconds, and then what's going to happen is you'll see RST appear in the display. It will blink several times and then go out. So you're done. That's it. You have reset that, and that alarm code is gone. Moving to the right a little bit there is the sleep mode. If you touch that crescent moon, the unit goes into sleep mode, which just basically means it doesn't display the temperature. This can be useful if you have third-party temperature alarming systems and monitoring systems there that display the temperature locally. Sometimes we get calls at tech support where they're saying, well, your display says one thing, our display says another. Well, if they're in different locations in the unit, yes, you're going to get different temperatures. It usually isn't off by much, but they're not going to agree. The only way to get the same temperature is to take the third-party probe and put it in our bottle, or take our probe and put it in theirs where you have both probes in the same bottle. Then it should align, all right? So some facilities do that, some facilities don't. So if your facility does not want that as part of their policy, all right, so we can just put that display to sleep. it will still display degrees C or degrees F, so you know what it's reading in. And it still gives indicators as to what's happening there. When the compressor is running, COMP will be in the display. When the evaporator fan should be running, fan is in the display. So there are status indicators there, but the temperature goes away. And then finally, for the freezers, this is mainly a service tool for the freezers. You can manually initiate a defrost. This is mainly so that if you're running diagnostics on a unit, and if you want to check the defrost cycle, you want to check the defrost heaters, make sure it's doing what it's supposed to be doing, rather than waiting hours for the next defrost cycle to occur under the regular time sequence, you can manually initiate a defrost by touching that, holding it several seconds, and the unit will go into its defrost cycle. So it speeds up the troubleshooting process. So it's really a service tool. There are 2 levels of hidden menus to access higher functions in the control system. To access these, now this rule applies to all Follett equipment, even some older different control styles from a different vendor. To access these hidden menus, it is always the set or enter button and the arrow closest to it. That's the easiest way to remember it. I can never remember up, down. I remember positionally. Set button and the arrow closest to it. Put your fingers there, hold, wait, and what's going to happen is L1 will come in the display. You are now in level 1 of the hidden menus. If you need to get to level 2, which has even higher advanced settings, you have to release it. You can't just keep your fingers there and nothing will happen. Withdraw your fingers, do it again, wait, and you'll see L2 come in the display as long as L1 is still being displayed. Then it jumps to level 2. You're now in the second level of hidden menus. So that's going to bring us to our next video that goes through some of those controller settings. To display the current set point of the refrigerator, all you need to do is touch and release the set button. The current set point will be temporarily displayed, and then the refrigerator will return to displaying the simulated product temperature. To adjust the temperature, press and hold the set button until the display starts to blink. When the display is blinking, use the up or the down arrow to adjust the temperature setting to the desired set point, and then press set to accept the new setting. Follett refrigerators and freezers come factory programmed in degrees Celsius. If degrees Fahrenheit is preferred, that can be changed by entering the first level of hidden menu. Press and hold the set button and the arrow closest to it, which is the up arrow. Wait a few seconds, and then L1 will appear in the display. While L1 is in the display, scroll until UNT appears in the display. Press set, and the display will indicate C. Then use the up or the down arrow to change the C to F and hit set to accept the new setting. The display has now been switched to degrees Fahrenheit. All Follett refrigerators and freezers maintain a record of the peak high and peak low temperatures that the product simulation bottle has seen. This is a valuable feature, especially in refrigerators and freezers that are located in off-site clinics that may not have continuous temperature alarming. In order to access this, while the unit is displaying the current temperature, pressing the up arrow will show the highest temperature that the unit has seen since the last time it was reset. Conversely, pressing the down arrow shows the lowest temperature that the product has seen since the last time it was reset. To reset the values, while the display is showing either the peak high or the peak low, press and hold the set button until RST appears in the display. It will blink several times, and then it will go back to displaying product temperature. At that point, the values have been reset. The alarm settings of the Follett refrigerator. All right. So that's the min-max, it records those highs. What you may have noticed is that when we display the peak high temperature, it said 73 degrees. This relates to startup. One of the things that's important to keep in mind when you're starting up a new unit, the moment you plug that unit in, it is going to record whatever temperature is inside that cabinet, room temperature, as the peak high. So part of the startup should be someone needs to go back an hour or so later after that unit has had time to stabilize, and that value should be reset. And that way we have a meaningful peak high and peak low record of the cabinet temperatures inside that unit. There is a function that the unit has. There's a lot of menu options in these higher functions. And we realize it is possible for some of those to get reset accidentally or get adjusted to settings that they should not be at. Sometimes it just gets messed up and people don't know which end is up. The good news is all of these units have what I like calling a get out of jail free card. There is a reset function where you can reset the unit back to its original factory specifications, the original factory settings. So as I like joking, no matter how bad it gets messed up there, we can't clean it up, okay? But there are several things that need to be done before you actually do the hard reset, and we're gonna go through those now. First thing is there's some settings we need to know. We want to touch and release the set button so that we can see the set point. We should record that. It may not be what we set it for here at the factory, depending upon what's being stored in the refrigerator. Once we've got that value, then we're going to go to the set and the up arrow, and we're going to go into level 1 of the hidden menus. And we're going to check the alarm settings. The alarm settings are normally set during startup, which is why we're not covering them here today. So we want to check, we scroll until we see HA1, that is high alarm number 1. And you touch set, and it will show you the current setting. Then you hit set to back out of it. Don't hit an arrow, because if you hit an arrow, it's going to adjust it. Hit set to back out, and then use the arrow to scroll to LA1, low alarm number 1. You hit set, it will show you that value. Then we record both of those. Next thing that we're going to do, because we're still in level 1, is we go to level 2 by going back to the set and the up arrow, the arrow closest to it. And once we're in L2, we see L2 in the display, you're in level 2. We're going to scroll and we're going to go to the probe offset settings. This is how we calibrate the probe. The factory setting is 0 degrees. They are not offset at all. We'll be talking about probe validation in just a few minutes. So we want to go and find out what these are. So we want to scroll on a refrigerator to P1C. That's probe 1 calibrate. Hit the set button. It will show you if any offset has occurred. If it's not 0, the value should be recorded. Then we hit set to back out. Then you hit the arrows to scroll to P3C, all right? And again, hit set. It will show you the offset value on the bottle probe, all right? And the same thing, if it's not 0, record the value. Only time we have to worry about P2C is on a freezer. And if we are on a freezer, we should do that as well. So we now have all of the offsets recorded. Now we are ready to reset. You scroll until you see RST in the display, all right? And then you press set. And what's going to happen is you're going to see no in the display. You use the arrow to change it to yes. So you see, this is a very deliberate action. No one is going to do this accidentally. You change it to yes, and then you hit set. And that resets the values to the original factory settings. And then all we need to do is we go back into our offsets, our temperature setting. We just change those all back to what they were that we recorded, if they were anything other than the factory settings. One other thing, on REF4Ps and REF5Ps, we made some changes to that. We made some changes to several of those settings, and they weren't from the original ones. We found that we could enhance the unit's performance by making these changes. So the original units may have had these enhancements manually set in, and when you do the hard reset, you take them out because you're going back to the original settings. So anytime you're doing a hard reset on an REF4P or an REF5P, there are a couple of settings that you should go in and verify. And here they are. And we will be sharing this with you. I think, Cindy may have mentioned that we're recording this, and you're going to get a link to this recording, so you'll be able to go back and see this if you'd like to. And you want to scroll. This is in the second level of hidden menu. DFD, which is a defrost termination time. DTT, and that's your temperature. Shoot, I can't remember. It's been a while. In any event, this is what you're looking for. EFD, DFP, that's probe 1. That's our defrost termination probe. These are on the refrigerators, okay? And P2P as needed. We're going to adjust those to 0. This is on refrigerators only. So you want to make these changes. So if you go into each one of these settings and you see a value other than the one being displayed, then you want to make that adjustment. Now remember, defrost termination time limit, defrost termination temperature, okay? Fan delay. When the unit's shut down, we run the evaporator fan for an additional 20 seconds, and our defrost termination probe is going to be probe number 1. The original ones were probe number 2. And so, like I said, these enhance the unit's performance. So that's it, the hard reset. And again, if you have questions, if you're unsure, talk to tech support. The guy will talk to you right there while you're working on the unit, okay? And we'll guide you through that if that's, if that makes things go a little more smooth. Alarm codes. What are some of the more common ones that you might see in the display? Well, HA1 is your high temp alarm. LA1 is your low temperature alarm. Low battery. This will only be seen on units with a keypad lock option or with a touch screen. Those units have battery backup. They have battery backup on the keypad lock again. So if the unit is in an off-site clinic without backup generators, if there's a power outage, the staff can still get to the medications. The batteries will power only the lock. That just allows them to open the door. On the touchscreen version, it will allow the unit to continue to monitor data and events. So that's the purpose data and events. So that's the purpose of the battery pack on the touchscreen models. DFA, defrost alert. We're going to get into the specifics of the defrost cycle when we get to the electrical section, which is coming up very shortly. The defrost will terminate either on time or temperature. We want it to terminate on temperature. That means that as soon as that evaporator gets to 41 degrees Fahrenheit, 5 degrees C, as we heard when we were looking at the defrost components, we want to terminate right then and there, because the longer we stay in defrost, the longer we can't provide cooling to the product. Now, if for whatever reason the defrost time gets extended, there's a time limit on each unit, which we'll be showing you in just a moment. If it terminates on time, you'll get an alert to let you know that happened. And so a little investigation is called for to determine why that's going on. Also, the board monitors kind of the condition of the probes. If the board is getting a reading from a probe that makes no sense to it whatsoever, it will tell you which probe is the problem. It means that either it's not sensing, it's either open or it's shorted. There's something wrong with that particular probe, and it will let you know which one is the problem. So you can go right to it and basically, figure out what's wrong there. So next up, we have our next video, and this is on the temperature probe validation process. This is what I was mentioning about doing offsets if required. How do we validate and make sure that that probe is monitoring temperature accurately? And it is the probe validation process. Next, we're going to talk about probe validation. There are 2 temperature probes on every Follett refrigerator. There is a control probe, which is called P1, which is on under-counter and countertop refrigerators mounted on the back wall of the unit. And then there is the P3 probe, which is the probe that's in our product simulation bottle. That is the temperature that is shown in the display of the refrigerator. To validate the probes, we need to put together an ice water bath. How this is done is very important. It is not sufficient to simply put water in a cup and add some ice cubes. To properly construct an ice water bath, the cup needs to be completely and densely packed with ice, and only enough water to fill in the gaps should be added. Do not use ice from a freezer. Ice from a freezer is too cold. Use ice from an ice dispenser. To validate the probe, we are going to insert it into the ice water bath. In this case, we're using the P3 probe. Sufficient time should be given to allow the probe temperature to stabilize in the ice water bath. Once it is stabilized, it should read 0 degrees C. The specification tolerance on the probe is plus or minus 1 degree C. As long as the probe is within that range, the probe can continue to be used. If the probe is out of that range, the probe should be replaced. Then, as long as it's close, we can certainly adjust for that by going into the offset function. And the way that you do that is you press the set button and the arrow closest to it, the up arrow, until you see L1 in the display. Then you repeat the process until you see L2. You scroll until you see P3C, which is probe number 3, calibrate. You press set, and the factory setting is 0 degrees. In our example, the probe was reading 0.2 of a degree too low. So we do a plus 0.2 degree offset. Now that we have validated the P3 probe, we need to validate the P1 control probe. The first step would be removing the P3 probe from the ice water bath and removing the P1 probe from its mounting bracket on the back wall of the unit and placing it into the ice water bath. Then we need to change the display setting. We go to the first level of hidden menu by pressing the set button and the arrow closest to it until L1 is in the display. Then use the arrows to scroll until you see DPR, which stands for display probe. Press set and you will see P3 in the display, which is the factory setting. Then use the arrows to change the setting to P1 and press set to accept the change. The temperature display will now display the temperature of the P1 control probe. Now that we have the P1 probe in the ice water bath and we have changed the display setting to display the temperature of the P1 probe, the probe can be validated. If an offset is required, it's done the same way that we did the P3 probe. We go to the second level of menu and we display P1C to make any adjustments. Once all probes have been validated, it is very important to remember to change the display, the DPR, back to the factory setting of the P3 probe. After P1 probe validation is complete, it is very important to remember that when reinstalling the probe, it must be installed and connected to the topmost rung of the grill at the back of the refrigerator. Any other position can result in inconsistent temperature operation. So that's the validation process. One thing I'd like to mention there when we're talking about the constructing the ice water bath, remember I mentioned to not use ice from a freezer. Now, why is that? Remember that ice from a freezer is not 0 degrees C. It is not 32 degrees Fahrenheit unless that's the temperature setting of the freezer. Freezers are typically set for -10, -15. That's the temperature of that ice. So although it would stabilize eventually, that makes it a much more lengthy process. So you want to use ice from a non-refrigerated storage container, such as the storage hopper of an ice and water dispenser. They're not refrigerated. That ice is 0 degrees C. So that's the ice that we want to use for this process. And please be sure to construct the ice water bath the way that we indicated in the video. So next up, now obviously this process tests everything. It tests the probe, it tests the board, it tests the connection, it tests the entire temperature probe system as a unit, a complete system. Now, if that temperature is off by more than 1 degree C, you have a probe that is off spec. That's assuming that the offset is still 0, that no one has adjusted that. So if it's off by more than 1 degree C, you have a probe that is off spec, even though the board will allow you to go beyond a 1 degree offset. Please do not do that. You have a probe that's off spec. It should be replaced. If it's under warranty, let us know. We will send you a new one. The probe itself, we can double check this. It can be validated independently. And here is how we do that. These are what are called NTC probes, negative temperature coefficient probes. All right, and it is the spell out there of the allowance. Okay, for the probe value to be the specification. So when the probe is in the ice water bath, the resistance of that probe should be 27,280 ohms, or very close to it. All right. Remember, at the header there, it says kilo ohms. All right. So this is the resistance value we're looking for. So if that probe is showing off spec, we can double check it. We can make sure that it is the probe and not something in the communication harness, something in the connection to the board. We should validate it independently. Now, when you look at the connector where these probes get connected to the board, there is only a very, very small area of conductor available. So if you have probes with very sharp and fine points on the ends of the tips, you can get at that. Most of them don't. The probe that I use, the meter that I use, they are not sharp enough to get to those. So what I do in order to read that, take a small piece of 16 gauge multi-strand wire, strip it and cut individual little strands, and you can insert the strands into where the connector goes onto the pin of the board. and then measure across the two pieces of copper. All right. However, when you do that, you can't be holding both of them, because if you do, you're part of the circuit. You can only hold one. So make sure you're not part of the circuit. Wrap the wire around one if you can. Hold the other one if you want to, but you can't be contacting both of them. Otherwise, your body is part of the circuit, and it will give you an erroneous resistance reading. So we need to make sure that we're doing that accurately. So that's it. That's the probe validation process. Cindy, it seems like all is quiet there. No questions?
All is quiet, Ernie. No questions.
All right, we will keep going here, and that brings up the touchscreen model. So it's a different user interface. The control board is the same for either one. All right, and as you can see there in the upper right-hand corner, we're displaying the temperature, and if we have anything other than the P3, we'll display what the probe number being displayed is. We have a USB port for downloading data. Remember, as I mentioned, these units record temperature data, and they also do a little something else, which is very handy as well. So when the memory bank is getting near full, you can download that data to a flash drive for permanent storage on a computer system. You keep that record there. So one thing I'd like to mention about that USB port, it is for downloading data only. Please do not allow the staff to connect mobile devices for charging. Depending on the size of the mobile device you connect to it, this could damage the board. It's only for downloading data. It is not capable of charging mobile devices. So just a little heads up there, okay? System status indicators, I mentioned this on the basic control system here. We're doing the same thing, but we're doing it graphically. The fan blade means the evaporator fan motor should be running. A snowflake means that the refrigeration system should be running. And a melting snowflake means that the unit is in its defrost cycle. Control functions are over on the left-hand side. So the gear, you touch that if you want to get into the settings. The bell is the alarm. The middle one there, if you have a unit equipped with a light, you can turn the light on and keep it on rather than it just coming on when the door is opened. All right. And then your data. All right. If you touch that graph, you're going to be able to access the temperature data of the unit. You can display it either in chart form, graphical, or you can display it in a table. Okay. Date, time, and it gives you the specific numbers. You can look at it either way. There's also another log in there, and that is the event log. And this is the service technician's best friend. We finally have that missing piece of the puzzle we've always been dealing with. This unit records events. If the door is opened, if the nurses are loading a whole bunch of product into it, if the door is kept open for more than 1 minute, a door ajar alarm occurs, and that time and date are recorded in the event log. When the door gets closed again, pardon me, the time and the date are recorded. High temperature alarm, low temperature alarm, power outage. If a setting is changed, all of that is recorded. So you have the complete unit history here. So if you get those mysterious, the unit appears to be working fine, why did we get this high temperature event? You can go in and look at the same time period in the event log, and maybe there was a power outage. Maybe the nurses were loading a whole bunch of product into it and they kept the door open for 2 or 3 minutes. And now we're not troubleshooting refrigerators or freezers that are doing exactly what they're supposed to be doing. Right? And if ever you're not sure what it is you're looking at, there is screen-specific help on each screen. Just touch that question mark. It'll tell you what you're looking at. So we've got kind of tech support right there on the unit itself. On the display number, this one also records peak high and low temperatures. If you tap that number, it will show the peak high and the peak low since the last time it was reset. And you tap it again to reset it. If you would like the resetting option on that, you have the choice of doing it or not doing it. A third tap will show you the alarm temperature settings, which also can be viewed by touching the bell. That will give you access to the alarm settings. If we want to get into the settings menu, we tap the gear. And when you do that, this is the screen you'll see. That little gear will jump up to let you know that that is the menu screen that you're in. And as you can see in here, this is where we can adjust our temperature set point. We can choose degrees C or F. It comes factory set in degree C, but we can switch it to F if you choose to. The revision level of the firmware on the board, if you touch that, it will show you that. And as long as it's the original board, it also has the unit serial number. Now, if the board gets replaced, obviously that feature is gone. because we won't know what that replacement board is going into. So if we want to adjust the set point, when we touch this, a numeric keypad will show up with some arrows, so we can scroll, we can adjust that temperature up and down using the arrows, so just enter the number directly into the keypad. You can just input the number directly. The key thing is, when you're done, be sure to hit the check mark to accept the new value. If you don't do that, it's going to stay at the previous setting. It's not going to adjust, even though you changed the number that was in the display. Then, all right, also, we have a sleep mode here as well, which we can set for time setting. Touching the screen wakes it up so that you have all the features available to you again. Anything above and beyond that, we need to go into advanced settings. These are the higher functions like the L1 and L2 of the basic control system. So what we do is we hit advanced settings, and once again, a keypad will appear, and the factory code to get in there is 4 ones. 1 1 1 1, hit the check mark to accept it, and that will take you into the advanced settings. So, any questions on the controller operation before we dig into the electrical system?
Ernie, I don't see any questions.
Cool, then we will move right along. So this takes us to our next video, where we're going to look at the locations of the, and also the operations of the under-counter refrigerator control system. Inside the electrical box, we can see the electrical control board on the right and the control relay on the left. On the control board on the bottom, the two probes are connected, P1 and P3. The center connection for P2 is open. If this was a freezer, the defrost termination probe would be connected here. The relay has a black and a red wire going from the control board to the coil of the relay. The relay is polarity sensitive. When replacing the relay, it's important to remember that the red wire has to be connected between the R1A terminal on the control board and the number 3 terminal on the relay. The black wire goes from the R1B terminal on the control board to the number 4 terminal on the relay. If the wires are accidentally misconnected, the relay will not be damaged. However, it will be inoperative. The system will not run. The power comes through the power switch, goes through the black wire to the L1 terminal on the control board, where a jumper wire brings power to the power side of the contacts of the relay. The load side has the orange wire that goes over to the compressor and to the condenser fan motor. On the right-hand side of the board, we can see 3 connections grouped together. This is where the communication cable coming from the user interface is connected to the board. All 3 of these are like USB ports. They all do the same thing. That connection can go to any one of those 3 connectors. The significance of what I just said there on those 3 connectors, and I'm going to bring up the schematic here because you can see it a little more clearly. Here are those 3 connectors I was telling you about. So there are other components on our upright refrigerators and freezers that get connected there. The board will automatically detect and translate and know what it's talking to there. That's why I kind of refer to them as, to think of them like USB ports. So the display is connected over here, as we saw in the video. And on the uprights, there are other things that get connected to them as well. So it doesn't matter which one you connect to, it will work connected to any one of those. So looking at this, when we power up the unit, so we've already run through it. Here's our condensing unit. Here's our evaporator fan. As you can see, the evaporator fan is the only thing that comes directly off of the board because of the low power requirement for that. Everything else comes through that outboard relay. It is a solid state relay. So in theory, it should last forever. It has no moving parts, but should it ever fail for whatever reason, you don't have to replace an entire control board. You can leave the brains alone. We're only replacing the muscle, just the relay. So when we power up the unit, all the power goes through the power switch. All right, so when you turn the power switch to the off position, you are powering down the whole thing, anything downstream of that power switch. And also, here, we already talked about the user display. All right, so the power is going to the L1 terminal, okay, and to the number 1 terminal on that relay. So the display, this can be either the LED, the standard controller, or the touchscreen. The board will know what it's talking to. It will translate it automatically. And it can go to any one of those 3 connectors that I first thing the board does is it energizes the evaporator fan motor. On countertop refrigerators, it runs continuously, all right? It never turns off. On under-counter refrigerators, it cycles with the compressor. So when the compressor is running, it's running. When it's off, that fan will be off as well. So when we're calling for cooling, and again, that's based on the P1 probe, that's the one on that return air grill on the rear panel inside the cabinet, then what's going to happen is the board is going to send 24 volts DC, okay, over to the compressor relay. There we go. And then we close the contacts and we energize the compressor and the condenser fan motor. As we mentioned, they're polarity sensitive, so just be aware of that. If they're switched, it doesn't damage anything, but the compressor won't do anything because the relay is not going to send any power to it. So when we are done, when we've pulled down the temperature that is detected by the P1 probe, all that happens is the control board shuts off the power going to the coil of the relay, and then of course the contacts open and the relay drops out. Now at that point, on countertop units, that evaporator fan continues to run. But on the undercounter, remember that setting that I was mentioning, the fan delay, it's going to run for an additional 20 seconds and then it will cycle off. So it runs 20 seconds additionally and that's it. Now the countertop units are pure off-cycle defrost. What that means is they have more than enough capacity that there is enough off-cycle time that they will defrost between each run cycle. So it's just running the fan and the ice will melt. If any accumulates on that evaporator, it'll melt naturally during the off cycle. The under-counter units do operate to a degree pretty much the same way, but just as a precaution, in case these are in units, in rooms that are small where the temperature tends to rise. We see that in hospitals in different locations. They have a defrost cycle. It is simply an air defrost. All that happens is 3 times a day. Every 8 hours, the unit will go into its defrost cycle, and all that means is that the compressor gets shut down and we energize the evaporator fan motor. Looks like we have a question.
Ernie, we do. Is 24 volts DC the common control voltage on all of the refrigerators and freezers?
Yes, because we're using the same control board today. Yes, it is. And I'm going to check that because I'm pretty sure it's 12, but now I'm second guessing myself because it's been a while since I've given this presentation. It's either 12 or 24. I am going to find out before the end of the presentation. I'll make sure that we know that.
All right. Thank you, Ernie.
Yep. For some, I'm doubting, I'm second guessing myself here. So all that happens again in this defrost cycle is we shut down the compressor, we energize the evaporator fan. So we're just using the air that's above 32 degrees in the refrigerator and circulating it through that defrost termination probe, which is through the evaporator. And when the P1 probe gets to 39 degrees, okay, which is 4 degrees Celsius, that is when we terminate the defrost. Or after 60 minutes, that's the length. And like I said, typically, if we terminate on time, you're going to get a DFA alert. All right, it's just letting you know. Now on refrigerators, that normally doesn't have big complications. It normally means that we have product shoved up against there. We're not getting adequate airflow through there. It's usually not an indication that there's anything wrong with the equipment. Now, freezer is a different story. All right, but on refrigerators, just look for some obvious stuff like they've got product packed up against that because that will affect the termination of the defrost cycle. So under counter and countertop freezer controls, we're going to the freezer now. We've got a few extra components that we have to add. First off, we have a second relay, all right? The second relay is what provides power for those defrost heaters that are on the unit during the defrost cycle. So we have on under-counter units, we have a defrost heater on the face of the coil, and we have a separate lower wattage one in the drain pan. That's just to prevent the water from refreezing. On the countertop units, it's all tied together, both the pan and the defrost heater itself. There is the P2 probe that I remember I was mentioning earlier. That's the one that measures the temperature of the evaporator coil, and we terminate that defrost when that probe gets to 5 degrees C, which is the equivalent of 41 degrees Fahrenheit. Also, freezers have a magnetic switch, all right, connected to the board. This switch is located on the lower front panel of the unit, and underneath the door is a magnet. So this detects when the door is open or closed. So if you open a door, All right, so I'm sorry, I'm going to get to that, getting ahead of myself again. So when we power up the unit, like the refrigerators, the fan motor is energized. On freezers, the evaporator fan motor runs constantly. Only time we shut it off is during the defrost cycle. The rest of the time, it's running always. All right, so we're going to, like before, cycling the temperature on the P1 control probe based on temperature there. Same as before, we're just closing the contacts of that relay. And what's different here is the defrost cycle. These units defrost 4 times a day, every 6 hours. When we get to the time limit of the defrost cycle, the unit shuts off the compressor and the evaporator fan if they were running. Then we're going to energize the coil of the defrost heater, closing the contacts and bringing on the heaters. So the defrost cycle is going to go for, there's a 20-minute time limit on a countertop. There's a 30-minute time limit on an under counter. But again, we want to terminate on temperature. It should take much less time than that. Yes?
From your experience, what is the most common wear item on the controls portion of the units?
On the control, the probes. I would say that's, the boards have been relatively trouble-free for us, the same as the relay. We don't replace relays. We haven't had them go bad. I would say it's probably the probes. That's it. Mm-hmm.
Thank you, Ernie.
Mm-hmm. Good question. Hadn't really thought about it. Had to think about that one for a moment. Okay. So, like I said, we want to terminate on time. It typically takes around 7 or 8 minutes on these units. It should get nowhere near these time limits. So when the probe is satisfied, when we terminate the defrost on countertop units only, remember these are the only ones with that evaporator that's on the ceiling of the storage cabinet. That's the one that's up there. So because of that different design, we go into what's called a drip time. Drip time simply means nothing happens. No fans are running, no heaters are on. It just allows additional time for that water to run off of the coil and go down through the evaporator drain pan and drain tube. All right, 2-minute drip time. And then we fire up the unit again. All right, there's no drip time on an under counter unit. But notice, we're only turning on the compressor. All right, we are not energizing the evaporator fan again. Well, think about this. We have a coil now that's at 5 degrees C. We probably have product out in the storage compartment that's at -20. So we don't want to be sending that heat out to where our product is. So we're only going to energize the compressor and the condenser fan motor to cool that unit down. So we're going to run that refrigeration system for 30 seconds. And at the end of the 30 seconds, that is when the fan is re-energized. So typically what we're seeing here, typical defrost time is 6 to 8 minutes. That's all it should be. All right. It should not be getting anywhere near that. Now, if at any time during regular running, remember the fan runs all the time, unless we're in a defrost cycle, if the door gets opened, the board detects that. It immediately shuts down the evaporator fan motor. So we're not going to be sending a whole bunch of very warm and humid air through the evaporator, which tends to lead to icing on the evaporator coil. So it shuts down the fan the entire time that the nurses have the door open. If they keep it open longer than 1 minute, okay, you get the door ajar alarm and we shut down the refrigeration system. We don't want to keep running the compressor without that evaporator fan running, all right? And so as soon as they reclose the door, everything restarts. Okay, we're not going to lock it out if they got a door ajar alarm. The moment it's closed, we go back to normal running, but that door ajar alarm has to be acknowledged. That's not going to go away. The visual alarm will stay there. So that's it for the operation. Now the DFA alert. Remember, on a refrigerator, it's almost always an issue of the way the product is loaded into the refrigerator. It can be other things, but it's very, very seldom, very rare. On a freezer, this is a different story. If we terminate on time, okay, what do we want to do? First thing we want to do is check to make sure that the defrost heater is working. And in some of our manuals, we have the specification on this. I know we can get it from tech support. I haven't bothered to memorize it because the nice thing about defrost heaters, they're either good or they're bad. If it's drawing current, it's safe to assume the heater is doing what it's supposed to be doing. But if you want to verify, like I said, those numbers are available from tech support. It is 12 volt. I knew it. I got it wrong. Okay, here we go. You want to check, okay, that you have output going to the relay coil. All right. If you've got no current, is it even being turned on? Sorry about that. It was 12 volt. I'm glad I second guessed myself. So let's make sure that the board is delivering 12 volts to the coil of the relay, and make sure that the polarity is correct, because if the polarity is incorrect, nothing happens. All right. So these are the two things that we want to check. If all of that looks good, then let's make sure that we're delivering voltage to the heater. All right. Check the voltage on the contact side, on the contact terminals there. Make sure that we're delivering voltage to the heater. If we are, but we're still not getting current draw, don't forget about that little clicks on, that little safety. Matter of fact, I'll tell you what, I'm going to back it up to the schematic so I can show you in the schematic where those are located. Here they are, right there. All right, those are the safeties. Now, they open at a ridiculously high temperature. It's like 70 or 80 degrees. So obviously, they should never open. If they open, you got some real problems. They're there as a safety. UL requires this. So if that relay gets stuck closed, we don't turn this thing into an oven. All right, so that's their purpose. They really do nothing more than that. And then finally, the last thing that we do, if all of that looks good, let's check the probe itself. Maybe the probe is lying to us. We've already gone over the 5 degrees, but the probe is not telling the board that, so we may need to validate the defrost termination probe. So that's the process for doing that. All right. Any questions on anything we've covered so far? Well, that's one more thing to go.
I didn't get myself unmuted. Any questions? So I'm going to begin then to unmute the audio.
We've got the refrigeration. I was going to go through that.
Oh, you were gonna go through
It's brief. It's only a little bit here. Okay. So next up is refrigeration. And what we've got here is this is just a chart showing you what we're using. So the rule of thumb today, all right, and all Follett products currently being manufactured. If it's a refrigerator, we're using R134A. If it's a freezer or an ice maker, it's R404A. Now, the exception to that is the original under-counter refrigerators. Those used R404A. They are distinct by they have the latch and the handle on the side of the door, and they do not have the plastic panel with the user interface across the top of the door. If you don't see the plastic panel, if it has a latch to open the door, that unit uses R404A. All right. If that's not there, any others use R134A. So on these units, our refrigerators today use cap tubes on the countertops and the undercounters. On the freezers, we use thermostatic expansion valves, not capillary tubes. Now, why would Follett do that? Remember, these are high-performance refrigerators and freezers, rapid temperature recovery. A capillary tube knows only one speed, okay? It is a fixed metering device, so it does not vary much based on load. It may vary slightly with changes in head pressure. That's it, okay? That works for a refrigerator, okay, because the load is fairly constant. What makes a freezer different? The defrost cycle. That changes everything. Coming out of defrost, you have a very warm evaporator, and frankly, for our goal here, a capillary tube doesn't cut it. Okay, it does not recover fast enough. Coming out of a defrost cycle, a thermostatic expansion valve with that bulb is wide open, and so we blast that refrigerant through there, rapidly bringing that unit back down to temperature, and the performance coming out of a defrost cycle vastly superior than the corresponding unit with a capillary tube. So that's why we want the thermostatic expansion valves on those. So here they are, the Ref 1 and 2, and these are the charge sizes. Just one thing, if you ever need to, this is actually coming up in the next slide, okay? If you need to service the refrigeration system, these are sealed systems, mainly because of number one, the very small charge size. Number two, capillary tubes. These are critically charged units. So for initial access, you'll need piercing valves, all right? But as I'm sure you know, the issue with piercing valves is over the long haul, they're not very good at keeping the Freon where it belongs. So permanent access valves should be installed, as you're concluding your work. We should put those on there before the final evacuation and recharge is done. And when you're recharging, please always charge by weight. Do not charge by pressures. There are times with an improperly working refrigeration system, you may be able to get correct pressures with an incorrect charge, and we're hiding a problem. What you need to do is evacuate, charge by weight, and verify that the pressures go to where they're supposed to go. And when they do, your work is done. If they don't, then and we know we have more work ahead of us. We've got to get in there, identify the problem, and then verify, make sure that we've taken care of everything. So that's it for refrigeration. The last thing we've got is just the Follett resources. I guess I should cover this, and we are running a little bit over on time. Should I skip this? What do you think, Cindy?
Well, let's continue on and cover it, but what I will do at this time is I will unmute people, and if you would keep the background noise to a minimum so Ernie can run through the remaining material for those people who've not seen it before, that would be appreciated, but you will be unmuted. You may need to unmute on your own device if you do want to speak and carry on an open discussion when Ernie finishes with this part of the presentation. If you do need to drop off, we thank you for participating with us today. As noted in some of the other webinars, we will be sending out links to all the recorded versions of these webinars next week with the certificates for attendance. So thank you again for attending, and back to you, Ernie.
Got it. Okay. When you're looking at your equipment, okay, you're going to see two nameplates. The larger plate is what we call the data plate. This is located on the back of the unit where it's almost impossible to see once the unit's installed. The good news is, as technicians, we really don't need it. This is there for the installers. This contains your ampacity information. The important one for the service tech is the little guy. This is your stock module identification plate. There are two of them, at least two of them, on each unit. There is one on the back near the nameplate, the data plate, but there's also one on the refrigerators and freezers on the inside of the cabinet on the left-hand side near the product simulation bottle. So you don't have to pull the unit from the wall to get the serial number. And if we zoom in on it, in this particular example, the serial number is only that letter and the first 5 numbers. That's your serial number. Everything that comes after that is a date code. So if you're wondering if this unit might still be under warranty, you can get an idea of the length of service by looking at that number. The last 2 digits is the year of manufacture. The number ahead of that is the calendar day of the year, the number of the calendar day of the year. So if you're calling tech support, they will be asking you for the serial number. Please have it handy. This just helps us help you more effectively. Certainly, we hope this would never happen to you, but if you should get an ongoing problem where the first solution did not take care of or deal with the issue satisfactorily, this way we have a complete unit history, and it just helps us help you more effectively.